Today we'll be looking at parallel and perpendicular lines. And if you look at our learning intention here, we need to recognize the algebraic significance of parallel and perpendicular lines. So in other words, we're going to have a look at how we can use our understanding of algebra to find the equation of parallel and perpendicular lines, and also introduce a new word called the perpendicular bisector. So first of all, let's think, what are parallel lines? Well, we can see here, if we have a look, that parallel lines are lines that will never intersect. And you may notice from this example of 2x plus 3 and 2x minus 4 that parallel lines have the same gradient. So the same gradient, but a different vertical translation. Or you might think of it as a different c. The y-intercept. Perpendicular lines are lines that don't just cross each other, but in fact cross each other at a right angle, as we can see there. So perpendicular lines are lines that basically have the opposite gradient. Now formally, that means that m1, the gradient of the first line, times m2, the gradient of the second line, should be -1. In practice, that means that the gradient of the first line should be equal to -1 on the gradient of the second. That is, m1 should be equal to -1 on m2. An easy way that we can think about this is that to find the perpendicular gradient, we need to flip and negate. So flip the fraction and put a negative next to it. So let's see what this looks like in practice. We're being asked to decide whether the following pairs of linear lines are parallel, perpendicular, or neither. So we're being asked to decide whether something is parallel, perpendicular, or neither. Now, these words we know have significance. They refer to certain aspects of algebra and geometry, so I'm going to put a little blue line to say that we have to have knowledge of what those words mean before we can begin. Now, what are we talking about here? We're talking about the following pairs of linear lines. And the reason that we're able to do this so easily is because we know they're linear. So let's look at the first pair of linear lines. We're given y equals x over 2 plus 4 and 2y minus x equals 5. So that's this question here. Before we can do anything, we'll need to think, let's get everything into y equals mx plus c. Y equals mx plus c. So the first one is fine, but the second one needs some manipulation. 2y minus x equals 5. So if I add 5 to both sides, or I mean add x to both sides rather, then 2y equals 5 plus x. If I now divide everything by 2, or each individual component by 2, then we get y equals x on 2 plus 5 on 2. Now we need to decide if they're parallel, perpendicular, or neither. We can call this graph y2, and we knew from before that y1 was already in that form, which is just x over 2 plus 4. Here we can see that the gradient for both of these is 1/2. So m1 equals 1/2 and m2 equals 1/2. We also note that the y-intercept of y2 happens at 5 over 2, or 2.5, and the y-intercept for y1 happens at 4. So since these have the same gradient, but a different vertical translation, or we're saying that their c values are different, we can conclude that these are parallel lines. So since m1 equals m2 and c1 does not equal c2, therefore, these three little dots mean therefore these lines are parallel. Let's see if we can apply this same method to part B. We're now talking about the two graphs here. 3x plus 2y equals -5. In order to get y on its own, 2y equals minus 3x minus 5. So that's a matter of subtracting 3x from both sides. And if I divide by 2, well, the first term, negative 3x on 2, and the second term, minus 5 on 2. So for my y1, let's call this the first y graph, I've got a gradient of negative 1.5, or negative 3 over 2, and a y-intercept of negative 5 over 2. Let's see if we can take the same method for y2. Well, if I add x, rather if I subtract x from both sides, minus y equals 2 minus x. And if I multiply by negative 1, one way to do that is to swap the order of these. So y equals x minus 2. Let's call this y2. Now if I think about the gradient of my first line, m1 equals negative 3 over 2. The gradient of my second line, m2, is equal to 1, because there's no number there. Our test here is, does m1 times m2 equal negative 1? If it does, we know these lines would be parallel. When we test this though, negative 3 over 2 times 1 is equal to negative 3 over 2. And so we know that these lines are not perpendicular. Given that m1 does not equal m2, we also know that these lines are not parallel. So we can conclude that therefore these lines are neither. For our last attempt, we've got y equals negative 3x minus 8 and y equals 1/3 x plus 1. So looking at these lines, it's quite clear to see that they're not parallel. They're both in the form of y equals mx plus c, but we know that our first gradient for y1 is equal to negative 3. And our second gradient, let's call it for y2, is equal to 1/3. So given they're not equal, they're not parallel, let's test for perpendicular. For these to be perpendicular, m1 times m2 has to equal negative 1. Well, negative 3 times 1/3, we know they would cancel, and indeed we're left with negative 1. Our conclusion here, therefore, these lines are perpendicular. Now, testing for whether or not lines are parallel or perpendicular is certainly one way that we can demonstrate the algebraic significance of parallel lines. However, another way is when we're being asked to find the equation of a straight line, and rather than give us a straightforward gradient or straightforward y-intercept, they give us some other information. Take example 2. We're being asked to find the equation of the straight line. Again, we get that really important phrase, which passes through. So this is the phrase that tells us always the context that we need to answer the question. Well, you may remember from 1g that this is our point x1, y1. The second part here, though, doesn't just give us a gradient. It says that it passes through 1, 2, and it's parallel to the line 2x minus y equals 4. So it isn't exactly that line, but it's parallel to that line. So the first thing, before we can label what we have, we need to find our gradient. So I have an x1, y1, which we know to be 1, 2, but I don't know what my gradient is. I do know that it's parallel to 2x minus y equals 4. So let's find the gradient of this other line, 2x minus y equals 4. If I subtract 2 from both sides, minus y equals 4 minus 2x. And if I multiply by negative 1, then y equals 2x minus 4. Remember that 2x minus 4 is the same as negative 4 plus 2x. Now the line that I want, which is not this y line, has the same gradient, has a gradient of 2. So I can now go back here and say, my m is equal to 2. With these two bits of information, we know we can plug them into a formula for finding the equation of a straight line. That is, y minus y1 equals m outside of x minus x1. We can sub in the values that we have, so that's going to be a 2 instead of y1. It's going to be a 2 for the gradient, and it's going to be a 1 for x1. If we now try and solve this function by adding 2 to both sides and expanding these brackets, we know y equals 2x minus 2, and then we need to add 2, which tells me that the line is y equals 2x, as minus 2 plus 2. So given this line y equals 2x, we might just want to double check, have we found the equation of a straight line? Yes, we have. Does it pass through 1, 2? Well, if I sub in 1, 2 times 1 is 2, so that works out. And is it parallel to the equation y equals 2x minus 4? Well, yes, they both have the same gradient too. So in this case, I know that I'm complete. We're also being asked part B to find the equation of a straight line, still passing through 1, 2, so that doesn't change. We've got 1, 2 equals x1, y1, but this time it's perpendicular to 2x minus y on 4. We're going to follow a pretty similar strategy. So we've got to label what we have, write out the formula, substitute in the values that we have. We need to evaluate or solve for y. And we can always check the context of our answer to make sure that it's an answer that makes sense and that answers the question. So looking at what we did before, we needed to find this equation in terms of y equals mx plus c before we could label our gradient. So minus y equals minus 2x plus 4, and if I multiply everything by negative 1, y equals 2x minus 4. So this gradient, let's call it y cross, because I don't want this graph. Well, this gradient, so m cross, is 2. The m that I want, let's call it m tick, has to be perpendicular to 2. So we flip the fraction, so 2 becomes a half, and we negate, so it becomes negative a half. What I'm saying here is that the gradient I want is negative 1/2. Plugging this into our formula for step 2, we've got y minus y1 equals m outside of x minus x1, as I know that gives us an equation. We can sub these values in now. My y1 was 2, and that comes from the point 1, 2. My m was negative a half, and my x1 was 1. If I expand these brackets first, I've got negative a half x plus a half. And I know that on the left-hand side that's been untouched, so y minus 2. In order to get y on its own, I just need to add 2 to both sides. So that's a process of adding 4 over 2. This makes it easier for me to add the fractions. So 4 over 2 is a number 2. That means that y equals negative a half x, and 1/2 plus 4 over 2 is plus 5 over 2. We can double check our answer here by saying, is my gradient of negative a half equal to 1 over negative 2, which I'm getting from here? Yes, it is. So this is the equation of the straight line, which is perpendicular to y equals 2x minus 4. Now example 3 once again asks us to find the equation. So always I'm going to have an answer that looks like y equals mx plus c. This time though, we're being asked we're being asked to find the equation of the perpendicular bisector. Now we're going to go through what that means. But that perpendicular bisector is a bisector of this equation between these points. Now a perpendicular bisector is a line that hits the midpoint of another line at a right angle. So what we need to know is that the line passes through the midpoint and is perpendicular to that graph there. So let's find out, what does it pass through? Well, if I had my midpoint formula, I know x2 plus x1 on 2 and y2 plus y1 on 2. So that would be 2 plus negative 1 on 2 and 0 plus negative 6 on 2. And so the line passes through the point 1/2 and negative 3. So that's one bit of information I need. The other information is that it's perpendicular to 2x minus 4. So if I had 2x minus y equals 4, and I bring that 2x over, minus y equals minus 2x plus 4. If I multiply by negative, y equals 2x minus 4. So the gradient, which is perpendicular to 2, remember we flip and negate, is negative 1/2. So this is equal to the gradient I want. It's perpendicular to 2. With those two bits of information, the process is the same. So I've got what I need. I've got m and I've got an x1, y1. So now I sub it into the formula, y minus y1 equals m outside of x minus x1. I know my values here, so I'll start subbing those in. My y1 is negative 3. My m is negative 1/2. And my x1 is positive 1/2. I might immediately see here that on the left-hand side I've got y plus 3, and on the right-hand side negative x on 2 plus 1/4. So negative x on 2 and 1/2 times 1/2 is 1/4. Negative 1/2 times negative 1/2 is positive 1/4. If I needed to subtract 3 now, so I get y on its own, y equals negative x on 2. Now, this is like saying plus 1/4 minus 12 on 4. It's the same as a value of 3. So I get y equals minus x on 2. Now 1 minus 12 is minus 11 on 4. So what have we found? Well, this is a line that is certainly perpendicular to this line here. But for it to be the bisector, it means it hits it at the midpoint. Our final example really is a Year 11 question. So I'm just going to label this extension. It says if two lines, 2x minus 5y equals negative 2, and 3x minus ky equals m, if they are perpendicular and they intersect at negative 1, 0, find the values of k and m. So what do I need to do? I need to find the values of k and m. What are the things that we're talking about? Well, we're talking about one equation, 2x plus 5y is negative 2, and another equation, 3x minus ky equals m. Well, there are those two things that I need to find. What information am I given? Well, I know that these lines are perpendicular, and I know that they pass through negative 1, 0. So let's start by taking my two things and put them in the form of y equals mx plus c. It's always easier to look at that way. So 2x minus 5y equals negative 2, which means minus 5y is minus 2x minus 2, so that's just me subtracting 2x from both sides. If I divide everything by negative 5, then y equals positive 2x on 5, positive 2 on 5. So let's call this my y1, my first equation. I know my second equation here, we might put it this way. 3x minus ky equals m, let's call this y2. Minus ky equals minus 3x plus m. And if now I divide by negative k, y equals 3x on k plus m on k. So that's my y2. Now how do I solve for k and m? Well, the other bit of information I was given is that they're perpendicular and intersect at negative 1, 0. So if I had a gradient for y1, which is here, 2 over 5, I know that that needs to be equal to this 3 over k when it was flipped and negated. Or I could say 1 gradient times the other gradient is equal to negative 1. Now this can be a little bit of a problem. I've just realised the gradient is not 2 on m, it's 2 on 5, which makes this problem much easier. So if I multiply the top, multiply the bottom, I know 6 on 5k equals negative 1. If I multiply by 5k, 6 equals minus 5k, and if I divide by negative 5, k equals negative 6 on 5. So that's one of the things I was asked to do. I was asked to find the value of k. I also know that they intersect, both these lines intersect, at negative 1, 0. So let's see if I can use this value of k to help me find the value of m. If I sub in my value of negative 1 and 0 for x and y, remembering this is a bit like saying when x is negative 1, y is 0, then my y equals 3x on k plus m on k becomes 3 times negative 1, and this becomes 0. So we can rewrite this as negative 3 on k plus m on k equals 0. Now you remember that we also found k is equal to negative 6 on 5. So negative 3 divided by negative 6 on 5 means we bring the 5 up to the top. So that's now going to be negative 15 on negative 6, or 15 on 6. Likewise, if I had plus m over negative 6 on 5, it's just a matter of bringing that 5 to the top. So I get plus 5m on negative 6. I'm just going to bring that negative to the top. Now I know that 15 plus 5m on 6 equals 0. If we multiply both sides by 6, we get the equation 15 minus 5m equals 0. I can solve this equation. Minus 5m equals minus 15. So all I did was subtract 15 from both sides. And if we divide by negative 5, m equals 3. So as I mentioned, this was really as hard as these problems get. But if we have sound understanding of what the question's asking, we can really solve just about anything.